Yeah, hi everyone. My name is Vikas Gupta, and today I'm presenting my scalable microservice based hospital management system built using Golang as a programming language, Gin framework of Golang, Docker and Kubernetes Minikube for deployment, and PostgreSQL as a database. This project demonstrates how independent microservices can communicate with each other and handle database operations and scale efficiently. For implementing this hospital management system, I have used different microservices. The first microservices is user services that will hold the data related to patient. Second microservices that I want to discuss is like doctor microservices that will store data related to doctors. For scheduling an appointment, I have developed appointment services that will responsible for rescheduling, updating, or deleting appointment. For successful appointment, there is a billing services that will create a bill. For payment related thing, there is a payment services, and to storing prescription, there is a prescription services, and notification services for successful uh, event to send notification. I have used K8 folder. You can see K8 folder is there. That is for Minikube deployment. So for that, there is all that YML file that will contain the configuration related to all the files in a single place. We can use different YML files also for each of the services, but I have used only single files. So coming to the demo part, I have already written all the steps here for easy and smooth demo. So first we will start from Docker. So for composing Docker daemon, we can use this command docker compose up. So first let me clear my screen and let's run docker compose up. So this is running all the services and starting. So total 12 services are there that is started here, and see five or six or seven microservices are there, and each microservices have their own database. So for uh, checking what are running or not, we can use this command docker ps-a, which it will show that these all the services running on this board. Like billing services are running on port 8083, appointment services is running on 8082, prescription services is running on 8087, user services is running on 8080, doctor services is running 8085, payment services is running 8082, and rest all of these are PostgreDB that is there. Notification services is running at 084, and this services is exited because recently Minikube is not started. To check this on Docker desktop, we can check here that all of the hospital management related services are listed here, and we can check that Postgre appointments database, Postgre user database, Postgres doctor database, billing database, notification services, prescription services, user services, doctor services, payment services, appointment services, and billing services all are running here. So for now let's come for Minikube deployment part. So for deploying it into Minikube, we can first start Minikube. So let's start Minikube. So we are starting Minikube. That will take almost 1 to 1.5 minutes for starting the Minikube. So let's wait for it, and then we can proceed for further things. Minikube is starting. Like we can check here, Minikube primary control plane mode node is Minikube cluster, pulling the base image from this, restarting existing Docker container for Minikube. It will take approx 1 minute, and then we can proceed for next step to apply all the configs that we have already defined here, all the YML for all the services we have decided, appointment services, prescription services, and then payment services, billing services. All of the services config is defined for Kubernetes Minikube deployment. So let's wait for a few seconds more for this starting the Minikube, and then we can proceed for this one. See, done. Kubectl is now configured to use Minikube. Now we can deploy this YML file. So this one is deployed, and after that we can check the pod status and get service status. So here we can check pod status. Doctor services is we are getting error for doctor services. Let me check and then we can proceed. So there was an issue on doctor services that is fixed, and now you can see all the services are running. This one is started 49 seconds ago. So these are all of the services. We can see that all are running. We can use all the services by using this command. So see, all of the services are there. So you can see all of the services are running with the node port that we have deployed at Kubernetes Minikube, and binded ports are there for 8082 ports at Kubernetes. We are using 30082 ports for this one. Billing node port is 30083. Doctor, Kubernetes, notification services, payment services, all are running perfectly. So we can check for Docker text, Kubernetes dashboard also for this one by using this command. So we can simply use this command and see all the deployed services are running. 11 services are there, and that are running perfectly fine. See, payment services, prescription services, appointment services, billing services, doctor services, notification, user, and all of the PostgreSQL database pods are also there, and replica set is also that Kubernetes Minikube already handle, that is listed here. Okay. So now let's come to the next part, that is demo flow part for inter-service communication, that I have already written all the steps, so we can quickly wrap up these things also. So for creating the patient, we can use this user command. This command invoke REST method for PowerShell. I'm not using curl or that Postman API endpoint hitting. We can simply use this invoke REST method, that we can use Windows PowerShell. So we can run this one. So they see the user patient has been created with this name and email and phone number, and role is also patient, and created and updated date is also here. We are also storing user response into user variable. For doctor services, we can use this one for creating doctor any. You can this doctor services, and doctor is created, and we are storing this into doctor variables, so that we can use while scheduling appointment or all of the things. So for this user, we can use for the same user, a patient that we have created, we can schedule appointment with the doctor that we have created. So we can run this one, and we can get appointment also. So see here, appointment is scheduled, created successfully, and we can see the patient ID, doctor ID. Reschedule count is also maintained in case customer or patient reschedule this, but it is for the first time patient has created the appointment, so that's why the reschedule count is 0 here. Let me clear the PowerShell screen. Now we can move for the next step. To mark up an appointment as completed, we can run this one, update appointment, by using the same appointment endpoint, and we can check this one. See, status is completed, means appointment has been completed, and after that we can use to create prescription. We can use this prescription API that is running on 8087 port, and we can run this one. So prescription is also created. See the message, create prescription scaffold. Okay. Now coming to generating bill point. So we can use the bill services that is running on 8083 port, and we can hit this endpoint, and we can see the bill ID has been generated for the appointment ID above, and the patient ID, doctor ID that we have created earlier. Amount is 500, and status is open, and the time at which the bill is created. After that, to make payment, there is a payment services, and we can run this to check that one, and see message payment has been created. We are getting from this, hitting this payment services. After that, all of the things had been done from the inter-service communication part. Now we can move into the DB part, where we can check all the database that we have created and check that. So for this, first we can use user DB for patient related things. So this one is the for that DB, and we can check user from here, patient and doctor. So see here we can see the user ID, name, email, phone number, role, department, specialization, created and updated it. So on the basis of role, there can be a patient and there can be a doctor also. After that, we have another DB, that is doctor DB. So for doctor DB, we can go into doctor DB and check for the doctor data also. And here we can see the doctor ID, name, email, phone, department, experience here created and updated. So all these fields are for storing doctors. So after that we can check another DB, that is prescription, for prescription related things. So we can log in first into this DB and check for that prescription or bill related thing or appointment related things. See, here we can see the appointment, and after that after appointment we can see the prescription also here, and prescription is there. See, for ID this prescription ID is this, appointment ID, for this appointment ID content is this, modification paracetamol, dosage and date for which date, and at what type of prescription has been created as listed out. After there is another DB for bill and payment related thing, so we can log in there and check for this one also. So see, by running this query we can get the data of bill. So here we can see the column bill ID, appointment ID, patient ID, doctor ID, amount, status, paid at and created. So all these fields are there for bills and payment related information. And after that we can move ahead for the next part. That one is health check, logs and etc. So for that one I am first clearing my screen, and after that we can use invoke REST method to check health of the any of the services. Suppose for 80 the services that we are running at 808 port, here the status is written okay, that means the services are running fine. We can check in similar way for some other services as well. For 8083 the services are running fine. For 8084 the status of the services are fine. We can check it by using docker ps command as well, docker ps -a. So we can see that all the services are up and running. So these are all the for checking the health of any services. And after that we can check log for any specific services by using this endpoint docker logs command. So for checking that one, docker logs command, we can check this one. Here if you get the log related to email and mobile number, that is already marked as PII data, so that is you cannot see simply here, and I have implemented for that one as well, masking those PII information. So that is already there. So PII.go in user services I have implemented for masking phone number or email, so that user personal identification data can't be exposed to internal or external people by any means. So that's all about my implementation, where I have shown you how multiple services are interacting with each other. And to summarize this demo show how multiple independent services, each with their own database, communicate and scale using Docker and Kubernetes. We observed end-to-end flow from appointment to payment to prescription, including health checks and log. This architecture is modular and fault tolerant and production ready for a hospital management ecosystem in real time. So that's all about my demo part related to my implementation. So thanks for your time. Thank you very much.